In today's video, we will demonstrate how to measure the wavelength of laser light, and we'll be doing it with a diffraction grating of known line density. Now before we begin, you're going to need to know the diffraction formulas. I prefer the second formula because it's easier to measure lengths than angles. Now I won't be deriving these formulas for you, that's for textbooks, but I will show you how to use them. Here's what the experiment looks like. I'm using smoke so you can better see the beam. The laser lands smack in the middle on the 50, but gets spread out 20 centimeters to the 70. Notice also that the laser starts 1 meter away from where it's going to be landing. This place is typically called the screen. The places where the laser beam lands are labeled as 0, 1, -1, 2, -2, and so on. You'll also notice that different colors get different amounts of diffraction. Less diffraction for green and less diffraction for blue. In our experiment, we were using the first dot, number 1, and it was a distance, the first dot, of 20 centimeters from the central dot, number 0. The wavelength we don't know, but we will calculate later. The length from the laser to the screen was 1 meter, and the distance is the distance between the lines of the diffraction grating, and we'll have to calculate that right now. The diffraction grating says that it has 300 lines per millimeter, but there's 1,000 millimeters in a meter. That works out to be 300,000 lines per meter. Thus, in 1 meter, there are 300,000 lines, or this is equal to 3.33 times 10 to the -6 meters per line spacing. That's D. Now that we know that the distance is 3.33 micrometers, we can plug it into the equation and figure out the wavelength. And when we do, the wavelength turns out to be 666 nanometers. Very close to the label on the laser, which says 650 nanometers plus or minus 10.